Hi everyone, Vega here. In today's video we're going to be looking at whether a solar shield could help us to terraform Venus. But before we start the video, don't forget to subscribe if you like this kind of content, because it does help me quite a lot. Okay, let's get to it. In this first depiction we see the solar shield and you see how it covers Venus from the sun. Hopefully in the future we'll be able to manufacture graphene to the extent that we create something like this, using solar powers for the maneuvers, docking it at the Lagrange L1 point between the Sun and Venus. It should serve as just enough to start to begin the process of cooling Venus down. In this next slide we see what's happening on the surface. As temperatures cool, CO2 condenses and begins to rain. That rain continues for decades, even centuries, until eventually CO2 begins to flow on the surface, as we can see here. It begins to collect at above 5 bars, and where CO2 still cannot fully liquefy. The atmosphere continues to rain out over decades. Eventually, all this carbon dioxide rain slowly condenses on the surface as the temperature of Venus cools 400 degrees, 350, even down to 200 now. It begins to condense. Carbon dioxide flows on the surface, as we can see, begin to collect, and we start to begin to see what we classify as oceans. The atmosphere continues to rain out over decades, centuries, until eventually we begin to see a difference in the cloud layers, water vapor cloud beginning to dominate over sulfuric acid. Indeed, for the first time ever, or perhaps on Venus, we see lightning striking, and it rains, but not carbon dioxide this time, water. We now move upwards from our white-coloured oceans. At 82% mass and 90% of gravity, Venus has now replaced Mars and Titan as the most Earth-like planet in the solar system. In this accelerated time-lapse, we see Venus, the blue. Cloud circulation has slowed, as there's no longer enough heat to continue this fast-paced movement. Our solar system now has a second blue planet. Earth and Venus, at last, are truly sister planets. Now we return to the surface, where we can see progress has been made. The sky is now a yellowy blue tint rather than just yellow sulfuric acid clouds, and the atmosphere pressures below 10 bars. They're rich in oxygen and nitrogen, but still toxic to the human lungs. Under the dome is a luscious, fertile new city is beginning to grow. We can see here the solar shield being used as a day-night cycle, where a normal day of Venus of 58 days of light and 58 days of dark has been replaced by a 24-hour system. The planet of Venus now has a capital city, at last. Still under the dome for now, we see the Venus night sky. Our city is coming to life. In the horizon, we see a pale blue dot in the sky, as well as a smaller grayer one. This is planet Earth from the Venus sky. At magnitude -2 to -3, Earth is the brightest object in the Venusian sky, outshining all but the Sun. Of course, the Moon is no longer so bright in the Venus sky as it is in that of Earth. Also, the Earth has less albedo and is further from the Sun. That's why it's actually not as bright as Venus is from the surface of Earth. It does remain, however, brighter than Sirius. At this point, solar power is running everything on Venus. With much more influx of sunlight, there really is no problems with power on Venus. It's as much as we want, really. Imagine arriving into our capital city on a boat, flowing in one of the few oceans on Venus. There is a shortage of water, so there wouldn't be all that much. Imagine the dome now gone, being able to walk around and explore the surface of Venus with breathable air, floating on a tropical lake with luscious vegetation, with trees, huge trees that could outgrow anything we know on planet Earth. A tropical paradise. A 1960s dream has been realized by the power of a solar shield. Let's look forward to one day when Venus becomes our second home. Thanks for watching. Hope you've enjoyed the video. Don't forget to like and share if you can, and I'll see you on the next one.